Hello students, today we are learning about capacitance in an AC circuit. A capacitor is a device that stores electrical energy in an AC circuit. A capacitor does not store energy permanently. Instead, it stores and releases energy continuously. When the AC voltage increases, the capacitor charges. When the AC voltage decreases, the capacitor discharges. This continuous charging and discharging makes the capacitor act like a temporary energy storage device. Because of this charging and discharging process, the current leads the voltage by 90 degrees or pi divided by 2 radian. The voltage lags behind the current. This makes the current flows first and the voltage follows. A capacitor also behaves differently with different frequency. It allows high frequency AC signal to pass easily, but blocks low frequency signals and DC. So capacitors are very useful in filtering circuits. Energy in a capacitor is stored in the electric field, not as heat. That is why capacitors do not consume real power like resistors. Instead, they manage what we call reactive power. Now let's understand the current flow. Maximum current flows when the voltage is changing fastest at the 0 point. Zero current flows when the capacitor is fully charged at maximum voltage. Mathematically, voltage V is equal to V naught sine omega t. Current I is equal to I naught sine omega t plus pi over 2 radian. This shows that current is 90 degrees ahead of voltage. Now let's talk about opposition to current flow. In a capacitor, opposition to AC current is called capacitive reactance, XC. The formula is XC is equal to 1 over 2 pi FC, where omega is 2 pi F, and F is the frequency of the AC source. C is the capacitance of the capacitor. This tells us that when frequency increases, capacitive reactance XC decreases. When frequency decreases, capacitive reactance XC increases. So low frequency, high opposition. High frequency, low opposition. This is why capacitors block low frequency signals but allow high frequency signals. If you draw a graph of capacitive reactance XC versus frequency F, you will get a downward curve like this, showing that reactance XC decreases as frequency F increases. Finally, capacitors are used in filtering, phase shifting, motor starting, signal processing, energy storage, power factor correction in AC circuits. You should note this: how to know if your air conditioner needs a capacitor. When your air conditioner powers on, listen carefully. If you hear strange sounds like buzzing, humming, or clicking coming from the outdoor unit, it could be a warning sign. This sound often means the compressor is struggling to start properly. And one common cause of this problem is a weak or failing capacitor. Apart from air conditioners, many household devices use capacitors too. Refrigerators, fans, washing machines, water pump, and even blenders can show similar signs when their capacitors are weak. So when a device powers on but does not work properly, showing slow movement, producing humming sound, or the motor struggling to start, the problem is often not the motor, it's the capacitor. Examples. Question 1. The phase difference between wave P and Q in the diagram above is... Let's look at the graph carefully. We can see two sinusoidal waves drawn on the same time axis t. One wave is labeled P and the other is labeled Q. They have the same shape and same frequency, but they are shifted horizontally. This horizontal shift is what we call phase difference. Since the shift is 1/4 of a circle, the phase difference is 1/4 of 2 pi. 2 pi is a full circle, so phase difference will be equal to pi over 2. We shouldn't get confused. Frequency does not change the capacitance of a capacitor. Capacitance is a fixed property of the capacitor and is constant no matter the frequency. Question 2. A capacitor of capacitance 25 microfarad is connected to an AC power source of frequency 200 divided by pi Hz. Calculate the reactance of the capacitor. First, let's recall the formula for capacitive reactance, denoted by Xc. It is given by Xc is equal to 1 over 2 pi Fc, where F is the frequency of the AC source and C is the capacitance of the capacitor. Now let's plug in the values. We have the capacitance C is equal to 25 microfarad, which is 25 times 10 raised to power minus 6 farad. Frequency F is equal to 200 divided by pi Hz. So the formula becomes Xc is equal to 1 divided by 2 pi times 200 over pi times 25 times 10 raised to power minus 6. Below here, pi will cancel pi, and 2 times 200 will be 400. 400 times 25 will be 10,000. The equation becomes Xc is equal to 1 divided by 10,000 times 10 raised to power minus 6. 10 raised to power minus 6 will go up and become 10 raised to power 6. And 1 divided by 10,000 is 10 raised to power minus 4. 10 raised to power minus 4 times 10 raised to power 6 will be 10 raised to power 2, which is 100. Final answer 100 ohm. And that is it. If you like this video, give it a thumbs up. And I would love to hear from you. Share your thoughts with me. Next lesson, inductance in an AC circuit.